Integrated trace can be a huge advantage for any engineer because it gives you the ability to see the interaction between any two variables. This could be bits, bytes, words, or tags. And this is true for your entire system architecture. Let me show you how easy it can be. As you can see here, I have the S7-1500 controller, have the E200 SPIO distributed, and a comfort panel. Over here I have the G120, all of which is on Profinet, and this is what I want to do the trace for. Alright, the first step would be is come over here to my project. Let's double click on the trace. Now we're going to pull up the actual dialog boxes for this. First thing I want to do is create a name for this one. It's called trace test, for instance. Click enter. Next thing I want to do is start applying the actual variables that I want to look at. So the first thing I want to use is IntelliSense and just type CON for conveyor on. So this is going to be our rising edge to start this trace. Next thing I want to do is find an analog value, and let's use conveyor position. And then last but not least, let's use another analog value of conveyor speed. If I want to change an attribute for one of these, for instance, I want to change the colors. Let me come over here to the conveyor position and change it to blue, for instance. And let's do the same thing for speed, just so we have red, blue, green for this particular trace. If I want to change the sample rate, I can easily do that here as well, however many samples I want per cycle. And last but not least, I even have a trigger that could be based off of a tag, so that way I gather information before the actual event occurs. Next thing I want to do is give focus to the CPU and click Go Online. The way you'll know that is you'll get orange bars across the entire top of the software. Next thing I want to do is go over here and just give focus to the trace test and move it over into the online mode. You get a little dialog box that says, hey, do you want to enable this trace? Yes, I do. At this point, I'm going to come over here and I want to choose this particular trace to start. Let me reconfigure what it looks like on the screen. So now I want to activate this trace and start gathering data. What I can do now is come over here and turn on this drive. You can actually clearly hear it's on. And let's actually start some absolute moves to start gathering actual data. So our motor's turning. We are gathering data. We've had the pre-trigger. And let's do another absolute move real quick. So we have at least two different things to gather into this particular trace. There's our first curve, and let me turn this guy off, and there's our second curve. So now we have our particular trace. So what can we do with it? Well, I have a full set of user tools, that way I can analyze it directly in the software itself. One thing I can do is actually give focus directly to it. That way I can actually see just the data that I want to see for this particular trace. Now that I've done that, I can even see all the data points by clicking on this button. And in fact, I can even see deltas in time and amplitude. So for time, let me choose these bars. Let me pull it back to our actual trigger. There it is. And let me go to the in position to see the delta time. And it took exactly 7.1 seconds. I can see amplitude as well. Let me pull the bars in. Let me go to this particular position here. And let me go to this particular position here, and our amplitude is a delta of 4. Well, I can even take this particular trace to a recorded trace, give focus to it, right-click, go to Export Measurements, change it to a CSV file, and save it directly to my hard drive so I can use it in Excel and do further analysis there. I was able to accomplish all this in just a matter of minutes. Now that's engineering efficiency.